He earned undergraduate degrees at Oregon State and the University of Karlsruhe in Germany, where he worked at the Karlsruhe Atomic Research Center. He then completed his master's degree in physics at the University of California, Irvine. Greg has been teaching physics at LBCC for the past 15 years. His courses include physics with calculus for scientists and engineers, astronomy, engineering, and energy and society, microcontrollers, and computational physics. If you know about any of those, it's going to be a good course. He's active in the American Association of Physics Teachers, focusing on studying how people learn physics and how to build communities of practice. Greg leads LBCC's remotely operated vehicle team, otherwise known as the ROV. The team has spent several summers doing ROV research at Central Oregon lakes and aboard research vessels such as the Atlantis and Nautilus. They also compete annually in the Maritime Advanced Technology Education Center's International ROV Competition, which is considered by many in the field as the World Cup of underwater robots. In the 2014 competition, LBCC's team won the top engineering evaluation in the Explorer class and the Grover Award, given in recognition of the team which exhibits courtesy, kindness, and professionalism and assists other teams providing technical as well as moral support. It sounds to me like the teacher is teaching more than just physics. Greg's academic interests include computational physics, physics education research, and the use of Arduino microcontrollers to control underwater ROVs. Even more fun, Greg likes to travel to archaeological sites to visit ancient astronomical observatories. He speaks German and visits Germany frequently. He also enjoys playing ultimate frisbee here in Corvallis and finding pickup games while traveling, at least according to his Facebook page. He also thinks that someday he'd like to star on TV in a detective show based in Hawaii, where he'd get to wear scuba gear while doing underwater investigations. I found some student comments on the website Rate My Professors, where his overall rating was only 4.7 out of 5. I suspect he had earned a 5, except that his average was pulled way down by getting several 2s on easiness. One student wrote, "This is not an easy subject, but he finds lots of ways to make it interesting and ties it to everyday life. If you want to learn physics without learning to hate it, take his classes." Another comment, "Greg is easily one of the best teachers I've ever had. He's passionate about physics and loves to see people get it. Great instructor, very caring. I was afraid of physics and not interested in it. It turned out to be my favorite class." Lastly, he's known as a dynamic teacher who knows how to hook an audience with fireworks and explosions. So be alert. Please join me in welcoming Greg Mulder.
Thanks, that was very kind. I wasn't sure you were getting all that information until you mentioned Facebook. Check my Facebook page. Now, before we get started, I'm going to hand something out. If you'd all grab one of these and pass the rest of the box around, I'd appreciate it. We'll meet in about 5 minutes. And I'm sorry to say that there won't be any fire or flame. Last night, while eating dinner with my significant other, it was pointed out, "Have you asked permission to set things on fire in the library?" And I said no, and I ended up asking permission, and they wanted a few more days' notice. So, but we'll have other things to do. Okay, so this particular book is about Freeman Dyson. I've had the chance to meet Freeman a couple times, just very briefly. Usually when he's giving a presentation somewhere, I usually have the chance to sit a few minutes with him afterwards. Truly, he's a very kind individual and very motivated to learning more about the universe and helping other people learn more about the universe. And I think the book itself does a really good job of probably in capturing who, at least in my experience, he seems to be. And the biographer in this case actually did not get to meet with Freeman directly. So Freeman had no input himself in the creation of this textbook other than just giving the blessing to the author. And everything the author collected came from an assortment of other people. And that makes it, for me, kind of an odd biography that the person it's about didn't have any input on it. And well, as we go through this, we'll see what it's turned out to mean. Okay, so the book starts out talking about Freeman in his very early years. He was born in around 1923, and from the very, very beginning, it was very clear that Dyson was smart. He really enjoyed reading. He kept a lab book of sorts where he put all his drawings of what he was what he was investigating at the time. I think here he's studying the Aurora Borealis at about age 4 or 5 or something like that. And I think he's drawn pictures as I look at this. So, I grade student work a lot in lab books, and so I'm very good at interpreting, I think, what lab books are supposed to say. And I think what this particular lab book of Dyson's at age 4 or 5 is saying is that the Earth has magnetic fields, and charged particles are hitting the magnetic fields and wrapping around the field lines. At least that's how I interpret this particular picture. I'd have to ask him directly on what it really means. And being very clever as a young child in England at this time, he found often his classmates would, tease him a little bit for being smart. And as people of that caliber often do, he spent a lot of his time in a treehouse reading science fiction. And one of the things reading this particular book did for me is it's caused me to want to read 5 or 6 or 7 other books. And if you notice that there is a cart back there with a whole bunch of books that are related to Freeman Dyson in one way or another. And one of the quick things I discovered is an author named Olaf Stapledon, which was apparently very instrumental for Freeman. And I had never, ever heard of this person. So I now have the next several weekends of cold nights planned out. So I think we know a little bit about his character, and that he was interested both in science and how science might impact society in the far future. So skipping through grade school and middle school, he was accepted into high school at a boarding school in a place called Winchester. And Winchester Boarding School is kind of rated, at least they consider themselves the top school in the nation. And so do other people. His middle school is so honored to have Freeman have one of their students go to this very prestigious school that they actually canceled school for a day back at his middle school in honor of that. Which canceling school to honor someone going to a good school, that caused problems for me. But apparently it was very prestigious to go there. And he was immediately recognized as top of his class when he got to Winchester. So in many ways, he was just instantly recognized very early on as just the top of the top. Now, you have to recognize the time he was going to school. World War II was just about to start. World War I was a couple decades ago. And you see here in the bottom picture is a war memorial for when Dyson was there. It was just for World War I. Now, of course, it's for World War I and World War II. And when you would go through the hallways and look at the classes of, I guess it was roughly 1918 and such, and look at all the pictures and those who were killed in the war, I think it was around 70 or 80% of Winchester graduates from these particular years were killed in World War I. So Freeman often talks about not expecting to live long. In particular, there was a well-known mathematician who wrote a couple of good papers at age 19, died in World War II a couple of years later, and so this was the sum of his work. And so one of the things Dyson felt early on is, man, I got to get everything I'm thinking on paper because I might not be alive in a couple of years. And I'm very happy that I didn't grow up in an era where that was going to be a possibility. But it really, everyone from that era really changed their thinking and how they viewed the world. So maybe he was a little motivated to get a lot of work done early. Now, Winchester considered itself being the best school in England, and they didn't offer physics. And so personally, I'm not seeing, I think they need to go back and look at their reputation there a bit. So what Freeman did is he organized a science club, and he learned all of his physics early on by a textbook written by Georg Hughes. And here is the 3rd edition of the textbook. I have a picture of the 1st edition, but it was hard to see. So it's still out there, still in print. You can pick it up. It's kind of neat. And while at this high school, he also created a religion, or maybe it was a philosophy. I'm not sure what it is. But he was very upset that people were spending a lot of time hurting other people. So he thought if we simply recognize that really every individual is just one part of a larger whole, maybe we could do away with all this beating each other up. He called it Cosmic Unity. He didn't find any followers, which was kind of a bummer. Because what happens next is, what happens next is he goes on to college. And in the process of going to college, World War II is now in the process of really picking up and getting unpleasant. So he moves to Cambridge University. At Cambridge, he has to finish his entire degree in 2 years. Instead of because of how things were at this time, 4-year degrees got compressed down to 2 years. Often I have to cut classes because of budget cuts. You know, we have this is what a physics major is supposed to do. And of course, I want all my students to take 145 credits of physics before they get to their junior year at Oregon State or somewhere else. And the administration says, no, you have to cut some things out. And what they did during World War II at schools in England is they cut out 2 years of everyone's program. You get a bachelor's degree or the equivalent after just 2 years. So you took accelerated classes and then you went off to war. So I'm still upset about budget cuts, but maybe not as upset as I used to be. One of the things Freeman liked doing is today we call it buildering or parkour. I don't know if you've seen any students at OSU do this, but basically you start at one side of a campus and run to the other side, and if there's a building in the way, you just climb up and over it and back down the other side. I don't think this had a name back when Freeman did it, but here's some pictures of what it looks like today. And okay, one of the things that's going to become very clear in this book as we go on is that this book is it's sprinkled all throughout with names of people who every physicist knows. And I'm just real curious, how many of you have heard of Paul Dirac? Okay, that's a lot. Dirac, of course, did a huge instrumental part of quantum physics back in the 20s when quantum was starting. And he was one of Freeman's professors early on, and Dyson's comment about Dirac is that he was completely incomprehensible. And not just Dirac himself in person when lecturing, but also he found the textbook incomprehensible. And he complained that Dirac's way of lecturing was to have his own textbook in front of him and be looking down and reading directly out of the textbook to the classroom, which I find it funny that he argued that this was bad, because if you go online and watch Dyson himself lecturing, he does exactly the same thing. But he's really good at it, so go to YouTube and you can see some good lectures. And so this book is ostensibly about Freeman, but it turns out just to be about everyone else as well. And so it spends a good time talking about many of these other players, such as Dirac. And Dirac apparently, when he would interact in any way with other people, he would always speak very slowly, definitely having to process the question to come out with an answer that was worded correctly. And so one of Dirac's statements here was, I was taught at school never to start a sentence without knowing the end of it, which I think that Dyson's kind of the opposite. I think often he starts out and doesn't know where he's going. Or another player we'll talk about is even more that way. Oppenheimer is another name that's going to pop up a lot throughout the book, it turns out. And Oppenheimer, as well as Dyson, loved poetry, and Dirac didn't. Dirac said that the aim of science is to make difficult things understandable in a simpler way, and the aim of poetry is to state simple things in an incomprehensible way. I'm not sure where your feelings are on poetry. Last month's presentation was on poetry, and I think there's a lot of worth in it too. Dirac didn't see it, Freeman did. So in 2 years, Freeman gets his degree. It is not in physics, because he got to take very little physics, it was in mathematics. And then Dyson had to go to war. And you have to remember, going to war was a complex thing for Dyson to do. Just a few years earlier, he was, a pacifist, a conscientious objector, basically, without using those phrases. And having to take part in this war was, well, as we see some of the comments he makes, it begins to really set him up for other views he's going to have of the world and of our species later on. And one of the comments he makes, so what he did is he was part of the Bombardier's command. So he would help find better ways to, I'm putting this very bluntly, blow up German cities. And one of the statements he made is, on the night of July 24, we killed 40,000 people and only lost 12 bombers, by far the best we had ever done. And, you know, when you read that, it sounds pretty cold, but he was choosing his words very carefully here, in that, is it really the best to say that, hey, I just killed 40,000 people, where the other half of it was, you know, not so many of our bombers were lost in the process. And whenever he faces numbers or situations like this, where there's something bad going on, that also maybe there's a good side too, there's a certain bit of ambivalence with what does this mean? And we're going to see this more throughout his life and other things he's done. And he does go on many years later to talk about he was on the side that won. He wonders what would have happened if he was on the side that was lost. People in the similar position in Germany who were on doing his job were killed were executed during the Nuremberg trials. So he's got a very deep, nuanced, and, well, we'll see more. We'll get there. And one of the things that Dyson did is when he graduated, so he graduated from Cambridge, he went off to war for a couple years, did 1 year of the equivalent of a post-bac at Cambridge, and then was going to go off to America, because all his professors said, hey, America's where you need to go to meet the people you want to meet to be able to make use of your mathematics. And before he went to America, he spent a summer in Münster, which is one of the cities he helped bomb. He was really taken by how happy everyone seemed to be in the face of a city that was destroyed and there not being enough food to eat. One of the things he writes about a lot is he was always hungry during this summer in Germany. He also discovered he wasn't homosexual in Germany. This turns out to be important. While at Cambridge, and in Germany, he finally discovered he was interested in women. He was very unsure of his sexuality. He thought he might be gay because he went to Winchester. Okay, so again, one of the things that happens to me when I read a book, I have to read 5 other books. And so a couple nights ago, I had to sit down and read the history of homosexuality in Europe. And it turns out it exactly ties into Dyson's experience at Winchester. Apparently, at this period in the 20s and 30s, if you were at an all-male or all-female boarding school, you had lots of really intense relationships, and some of them were sexual, some of them weren't, and he didn't know what he was. And so in Germany, he discovered, I'm straight. And he met a woman in Germany named Heidi, I can't remember her last name, I'm sorry, and the book, So Dyson has lots of relationships, as everyone does, but Dyson moves around a lot. So I think his relationships are, as you read the book, they're all very disjointed, because he gets to meet these people and then doesn't see them again for 12 or 16 or 18 months, and tries to pick up the relationship where it left off. And I think that was often hard for the people who were on the other side of the relationship. Okay, now notice I put up lots of pictures of people. These are all, again, physicists that Dyson worked with. These are the ones he worked with his first year, now in the US at Cornell. And these are all names that people know. So Hans Bethe and Feynman are the upper two. They won Nobel Prizes. I guess they all won their Nobel Prizes after they met Dyson. And then the two below are his students in his very first year. Well, they were kind of his students. They tried to sit in on his class, but the class was too hard for them. And it wasn't too hard for them, they just hadn't had prerequisites yet. So they ended up going through the first 4 or 5 weeks, and it turns out they won Nobel Prizes later as well. And so he spent a year or two at Cornell, and then he moved on to his next place, which is the Advanced Study Institute at Princeton, which is where he spent the rest of his life. And although he retired a few years ago, I think he still has an office there. And his office was right across the hall from where Einstein's office used to be. Although he did have he crossed paths with Einstein several times, but never ever took the time to actually sit down and talk with him. He says, just because he didn't have any questions that he thought would have been relevant to Einstein. Okay, and Okay, I really like my job at Benton Community College. I get paid to play, I get paid to keep learning more about physics, but when I learned about this particular place where Dyson has worked at Princeton, I think this is even better. So if you look at this paragraph from their webpage, members of the Institute are free to work on any problem in which they are interested. And I think Dyson and everyone who's worked there is just really very appropriate for that job, and that Dyson has lots of interests. And so his job just gave him a lot of freedom to pursue what he wanted to pursue. Okay, so what Dyson started out with, and I think maybe what really made his name most known early on, was working on something called quantum electrodynamics. Okay, QED shows how light and matter interact, and this is where we're going to have to do a little bit of physics. And sorry, when I travel I have to do physics. So here is a model of an atom that you probably got somewhere in grade school or college. And in this model of the atom, the nucleus is at the center, and then the electrons orbit the nucleus. And this is called the Bohr model of the atom. Someone named Bohr developed it again in the 1920s. And what he was trying to do is he was trying to explain something that we're going to see with the little slides that got passed around. So did everyone get a slide? Okay. So what you're going to do is you're going to place the slide up against your eye, and we're going to try to turn these lights off, if you could help turn these lights off. And the way this is going to work, let me blank this string out here. Is you're going to put the slide right up against your eye. You don't need to take your glasses off. Close the other eye. And then you're going to look at any one of these three tubes at the front, and you should notice off to the right or off to the left, quite a bit off to the right or left, there is a red, a blue, and if you have good eyes, a purple line. If you see them, nod. Okay, cool, that helps. Okay, so this particular gas is hydrogen, and what I'm doing is I'm doing the equivalent of burning hydrogen, and then you get to see this, what we maybe call a spectral fingerprint, or a spectrum come out. And it turns out every single substance has a different fingerprint associated with it. And if I was allowed to burn things, I would now set things on fire so you can see different things. But we'll do that later if you ask. I'll tell you when and where.
The lights back?
Yeah, you can turn the lights back on. Thanks. And what is really nice about spectral analysis is one of the things we discovered around 150 years ago is that the universe was really, really big. So obnoxiously big that we can't even hope to get to the next closest star within a century. And spectral analysis was this great tool to make us feel better in that, hey, we can figure out what things are made out of, even if they're not here. If they're simply burning or doing a few other things that we can talk about later, it turns out you can see this fingerprint to say, hey, that sun must be made out of hydrogen and helium and other stuff. So, really important tool in physics and society today. And a person named Bohr tried to explain why we were seeing those lines. And in his particular model, he had electrons orbiting a nucleus of an atom, just kind of like a moon would orbit a planet. Except the difference is an electron can only exist here, or in any of these orbitals, and never anywhere in between. And when an electron goes from here to this next state, you can't see my cursor, I'm sorry, but I can use a pointer. When an electron goes from one orbital to another orbital, it never travels in between. So that's just like an airplane flying at 10,000 meters and suddenly disappearing and reappearing at 20,000 meters. You know, that doesn't happen with airplanes, but it seems to happen with electrons when they orbit nuclei. And this particular, okay, how many people have seen this model of the atom before? Okay, good. It turns out your teacher was completely lying to you. This is not how the atom works at all. But it's close. It does a good job of explaining what's going on. And what was happening in that tube is when we heated up the atoms of hydrogen in the tube, all the electrons jumped up to the outer orbitals. And then I turned off the heat I did it 60 times a second by plugging it into an outlet that was hooked up to a dam on the Columbia Gorge, but that's more physics we don't need to worry about right now. All the electrons move up to that upper orbital, and then over time, they fall back down. And when they fall back down, they lose energy in the same way an airplane would lose potential energy as it goes to a lower altitude. But energy isn't something that can be lost. It gets turned into a piece of light instead. A piece of light is a photon. And that spectrum that you saw is the light that is emitted from the electrons falling from different orbitals. And you get different colors of light depending upon how far the electrons fall, and because the electrons can only fall from one place to another place and never anywhere in between, you only get very specific colors of light out. Okay, so this is, and this allows us to do emission spectra. It turns out what's going on, the reason why electrons are allowed in only certain places has to do with the fact that we now know, and we knew this before Dyson went to Princeton, that electrons have a wave-like a nature associated with them. And so I'm going to quickly show one quick thing with waves too, just because we need another physics demo. And Jane, can I borrow you just for a second? Thank you. Okay, so we're just going to remind ourselves what's up with waves. Jane is going to very kindly hold on to the far side of the tube, and she's going to keep it nice and taut. Yeah, right about there. Okay, and then I'm going to turn this on, I hope. Okay. And, okay, so what I'm going to do is I'm going to use this jigsaw to send some pulses down this particular piece of surgical tubing. It's going to hit Jane's hands, and then the waves are going to reflect back. And it turns out when all these waves add together, we're going to get something called a standing wave. And let me try to show you a standing wave first. So what you saw there were nodes and antinodes. Nodes are the places where the surgical tubing was never moving. The antinodes are where it was vibrating the most. Now watch what happens when I go from a low frequency to a high frequency. So there's a low frequency. And hopefully what you noticed is in a high frequency, the wavelength got a lot smaller.
Yes.
Okay, cool. Thank you, Okay, so likewise, electrons have a frequency and a wavelength. And here you see, okay, again, this model that I'm giving you is not correct, but I think it is slightly better than the moon orbiting the planet model that we saw earlier. And when we hit the electron with a photon, when the electron absorbs some energy from a photon, it oscillates at a higher energy state. So that means that the wavelength is smaller, which means that it goes to a higher orbital because there's more distance to go around. More physics, you don't need to worry too much about that right now. But here is the important part, is a photon is a piece of light, it's energy. An electron is, we think of it as matter, we think of it as a ping pong ball-like thing, but we know that it's really a wave. And a question that was happening, we knew that this is how, during Feynman's time, we knew that this is how the atoms behaved, but we didn't know exactly how the interaction between the light and the matter happened. And that's what quantum electrodynamics does, amongst many other things. It tries to figure out how does that photon hit that electron, move it up to a different energy state, so it's oscillating now at a higher energy state, and then what does it do after that? And so, okay. One of the things I really like about teaching again is I get to spend summers and winter breaks going to conferences where I get to meet really fun, exciting people who teach me new things. They teach me more about physics, they teach me how to teach physics. I really like that a lot. And likewise, Feynman kind of had the same experience where a lot of the physics he did on bus trips on Greyhounds across the country, or maybe in, well, you have to read the book, but in really dank hotel rooms with a couple people who were interested. And so his story happens on the road a lot, visiting lots of different places. And a couple of the people he interacted with is Feynman. Feynman liked to describe the interaction of particles using what are today called Feynman diagrams. And there's math underlying this, but this was a very conceptual reasoning of how energy and matter interact. And then another person named Schwinger instead used a mathematical representation. And, okay, there's lots of math there, we're not going to discuss that right now. So I actually do review books for Harvard Press that are written for the general public, and apparently if you write a science textbook for the general public, you're not allowed to put any equations in it. Apparently a single equation decreases the sale of it by a significant amount. And I find that sad. But those might be more equations than you need. And one of the things that's happening in these equations that's kind of hard, well, I'll try to explain, is that a lot of these equations have an infinite sum in them. Remember, a sum is adding up a whole bunch of pieces of things together. And one of the problems that they were having back when QED was being developed was all these sums would go to infinity. And in science, we don't like it when our mathematical predictions predict things that aren't possible, like things going to infinity. And so what Dyson is known for is he's the one who figured out how to make the infinities go away. He did the math right far enough out that it turns out all the infinities don't go to infinity, and quantum mechanics is now good. I don't know if any of you read Bloom County. Bloom County was a comic strip, and Oliver Wendell Jones was the child scientist in the strip, and I should have put this comic strip in there. But as he's solving all of his equations, he can't find any reason or any reason that penguins or flightless birds should exist. And so as he's doing his math, Opus, of course, is beginning to disappear. And finally, Oliver Wendell Jones discovers that he forgot to carry a 2, and penguins reappear. Kind of the same thing here. The math was causing some problems, and Dyson figured out how to fix those problems to really explain what was going on. Okay, so I think that's kind of the first really, really big thing he did, and kind of that's what got his name spread all over the world, is he figured out how to make the math work. Okay, and then as we go on, so again, remember Dyson's working at this place where he gets to do anything he wants. And so one of the things he gets to do is he gets to spend a summer, I think it was in San Diego, where he gets to develop what is, actually there's one of these in Corvallis. This is a Triga reactor. This is a nuclear reactor that is intrinsically safe. And what do we mean by intrinsically safe? We mean this is a reactor where anyone could do anything to it and it just turns off. In this particular case, so one of the problems with a reactor of this, any nuclear reactor, is a lot of those, the blue glow you see down at the bottom, those little cylindrical things down there are fuel rods. That's where the uranium is. And if those fuel rods ever get partially exposed to air and the rest of it's underwater, then they begin to get really hot and they melt down. And that's called a nuclear meltdown. We don't like those. But what's kind of neat about this particular reactor here is that if the fuel rods ever do get too hot, then they just shut themselves down using the chemical physical properties of the fuel rod, which is a really neat trick. You definitely want fuel rods that shut themselves down when someone does something wrong. And so there's now just under 100 of these across the planet, right here at OSU. And these nuclear reactors are there to, number one, train nuclear reactor operators, but more importantly to also do science. Like if you get a rock from somewhere, you can throw the rock into a neutron beam right. Whoops, whatever you do, don't push that button. Okay, thank you. Right around there is a neutron beam that you can shoot a rock into. It does something called neutron activation, which creates a fingerprint, not unlike the one we saw there, that allows us to see what sort of minerals or atoms this particular rock's composed of. You can also do forensics. The OSU nuclear reactor helped track down someone who murdered someone else by doing neutron activation on the bullet casing. So you can do cool things with these. And so Dyson, so remember, Dyson was a mathematician. He's known for his work in physics. He couldn't take physics in high school because his school didn't have it, and somehow he just managed to avoid a lot of physics classes in college. And after being a physicist, after having never really been trained for one, he's now an engineer. So he really gets to do all these cool, amazing things. Meanwhile, in his personal life, and so for this book, for me, it's again, it feels disjointed to me in that it talks about his professional life and then his personal life gets scattered throughout it in a way that's hard for me to keep track. If I were to read the book again, I would have kept a flow chart so I could have seen, okay, what was going on. And what's happening at home is he's been married now for a few years. He's had a couple kids. They tried having a third child, and sadly the third child didn't live. Verena had a miscarriage. And that caused, there was a lot of stress in the relationship. And bottom line, see, there's lots of words here. If this were Facebook, under relationship, it would say it's complicated. And to make a long, and actually, what's really frustrating for me about this book is that there's so much that's happening between the lines. You don't get to see what it is. And I think it's because he didn't interview Freeman directly. All he did was interview the people he interacted with. That we don't really know what's going on. And Freeman's first wife was a mathematician as well. And there's a point in the book where she gathers up her PhD work. She has a PhD in physics, and I don't know if I pointed this out yet, but Freeman has never received, well, he's received honorary PhDs, but he didn't have a PhD at this time. And she ends up burning all her dissertation work because she's feeling like, there's math and there's family, and I can't do both. I have to choose one or the other. So in this very public display with Freeman there, she burns all of her work. She ends up going to Europe for a while, and while she's in Europe, it turns out Freeman has an affair. And okay, if there's ever a way not to explain to someone you just had an affair, it's the way Freeman did it. Basically, he did it through text message. They didn't have text messages then. But he sent a very short note with a poem in it. Remember, Freeman likes poetry, Duroc doesn't. Maybe you should have listened to Duroc here. But he says, "He who binds himself a joy does the wind life destroy, but he who kisses the joy as it flies lives in eternity's sunrise." And so basically he says, it was a great affair, it's over, don't worry about it. That's kind of the way I interpret this when I read the book. And we shouldn't make light of these things that are personally very complicated for people, but it turns out she goes on and has an affair about a year later, and his response is to kick her out of the house. Yeah. Now.
Oh, you had a Dreisel and a Kreisel. Are they the same person?
Yes, I'm sorry. Georg Dreisel should be Kreisel, so that should be a K right there. And I don't know if she ends up marrying Kreisel. They end up being together for a long period of time. But read the book and you'll get all the details, and maybe you'll make more heads or tails of it than I did. And actually, it's a good story, so you should sit down and read it. Something that was important, notice I have another typo here, I'm sorry, is divorce was really hard in the 1950s. And number one, maybe we shouldn't judge Freeman too harshly, because this was the 1950s, and Freeman was enlightened in many ways, and we don't know what else was going on in the relationship that made him feel like he had to kick her out of the house for this. But that being said, in today's climate, that's just not how things work. And the two did not see each other for 50 years until about 5 years ago. And what happened is Freeman's second wife, who was his basically au pair at the time that these two were married. And I see Jane cringing a little bit, but maybe again, you have to read between the lines. His second wife arranged a meeting with the first wife where the first wife was in the audience of a presentation that Freeman was given. And the reunion, you can actually see it on YouTube, was actually quite touching. So, I don't know, maybe it ended out okay, I'm not quite sure. Marrying your au pair, that also sounds kind of bad. Again, I'm not quite sure how sexually interested Freeman was. I actually think maybe this was a person who'd been raising his children for a couple years, and maybe this would be a good person to keep raising his children. They did go on and have, okay, another thing interesting about Dyson is very early on in his marriage, he said, I want to have 6 children. Well, it turns out he had 2 with his first wife and 4 with his second wife, so he did end up with 6 children. Again, I don't know if that was by design or just what happened. But that's those questions that he's not here, and that the book didn't answer. So as I read this book, I just have my questions. mind you, Dyson's still very much alive, so I feel very uncomfortable about examining someone's life in a very public way. I kind of wish he would have an interview with Terry Gross. Yeah, she'd nail it all. Okay, other neat things that Dyson got to work on is he got to work on a nuclear-powered rocket. The Apollo mission was about to happen. There were two ways to get things and people into outer space. One was using chemicals. One was using atom bombs, basically strapped to your behind. The idea is that you would blow up an atom bomb. There would be this plate right here that would be lined with certain materials to increase thrust and help protect the people inside the capsule from radiation. And then here's an artist's rendition of how it would work. You'd then launch it off into outer space. And again, one of the things about Freeman, at least the way this book portrays him, because I can't say this is real, is he's not quickly introspective, I think. He does things often because it's cool. And one of the first introspective things I saw him say in this book is that as he was trying to figure out, is this really the right type of way to get people into outer space, is the first shadow of doubt about the rightness of the Orion project, which is what he was working on, came into mind when he was looking at the silence in Jackass Plains, which is where this was going to happen, being interrupted by what he was doing. That being said, this could be a good way to get people into outer space, and an even better way to perhaps propel them once they get outside of the Earth's atmosphere. And the only reason why this technology was eventually given up, and Dyson might be instrumental in having killed this project, is the Anti-Ballistic Missile Treaty was in the process of being written. Sorry, not the ABM Treaty, a prior arms treaty. And, sorry, I'm going to have to skip one. And one of the things that was happening is we were doing a lot of atmospheric testing of atom bombs, and this is a graph. Not very often do graphs make it on the front page of the newspaper. This was a graph of strontium-90 in the milk. And it turns out all this aerial testing was increasing planet-wide strontium-90, and I think this, combined with the testimony of lots of different people, suggested that, hey, maybe we need to ban aerial testing, and maybe Dyson would have stepped further. He didn't only want to ban aerial testing, he eventually wanted to ban all testing, and he's one of the few scientists of that era, I think, who wanted to ban nuclear weapons, period. You have to remember, particularly for those of us here in Corvallis where we had Linus Pauling, the way we think we prevented World War III was by so many people having so many atom bombs that no one would ever be silly enough to try to use them. This mutually assured destruction is what many people say kept us alive and safe these past 50 years or more. So when he signed on with the aerial testing of nuclear weapons ban, he basically ended up killing his own project that he felt this was his baby. And when he and the people he worked with worked on this, they wanted to be the first person on the first launch. And so, that's a big thing in Germany, is if you make a new high-speed train, the engineers and their family are always on the first ride. I think that makes a lot of sense from an engineering point of view. And so I think he's personally sad. His daughter actually got a chance to be on one of the Soviet launches several years ago. She didn't get to make it, though, because of space issues. So, this seems to be a family issue. One more of the very fun and interesting ideas that Dyson had, and another thing, his name is attached to everything in math and science, but there's something called a Dyson sphere. This is also going to talk more about Dyson's personality that we'll get to in a second. But, so this is one of the things we get to talk about in one of the classes I teach, is the human race for almost all of our history has only used wood as an energy source. We burnt things, and that kept us warm, it allowed us to cook food, and what would happen invariably is our societies would get larger and larger and larger, we'd cut down more and more forests, and then suddenly the trees would be gone. That's one of the things about exponential growth that we can talk about later as well if you want. And then suddenly society would collapse again when the trees were gone. Europe went through 3 golden eras and dark ages. As the population grew, the trees declined, they ran out, and then society would collapse. The 4th collapse in Europe was prevented by finding a new energy source, coal. And coal allowed us to use, in the past century, 1 million years of stored sunlight. So it was this great new energy source. The new energy source after that was another fossil fuel, oil. After that was nuclear energy. And Dyson began to think, well, what's the limit of this? Where does the society get to the point where it's using the most energy it can? And he came up with the idea of a Dyson sphere. In this, a society would dismantle any planets that happen to be handily nearby and then build a big shell around our sun filled with ways to collect energy so that that species then can use as much energy as is available. If you think that this is a crazy idea, if you do the math at the rate in which the human race has been increasing its energy usage for the past 250 years, if we want to keep that rate up, we will need to encapsulate our sun within 3 centuries, which is basically tomorrow. Yeah. So Google Dyson Sphere. It turns out that there are actually 14 Dyson Sphere candidates out there. There's 14 objects we've found that might actually be Dyson spheres. And if you want more, just Google it. Well, be careful though. Don't believe everything you read, but that's okay. One more quick story that I think is worth telling is at this point in Dyson's life, he is walking in all sorts of policy circles, and he happened to be at a meeting, a dinner party, where this general, who was high up in the whole Vietnam thing, managed to just mention, I think we should drop atom bombs on Vietnam every now and again to keep it interesting. And Dyson just didn't believe he'd heard right. So he asked several other people, did I really hear this person correctly? And it turns out, yeah, there were a significant number of high-level people who wanted to begin using atom bombs in an everyday sort of war. And Oregon gets into this. It turns out that there is something called the Oregon Trail. Okay, there's the one we all know and love. But there was a supply line from the north to the south of Vietnam that was also called the Oregon Trail that the Vietnamese would carry arms up and down. And then, to confuse things even more, there was a report called the Oregon Trail that, if you read the report, it was done by a JASON committee. There's a book over there that explains what JASONs are. It turns out the JASON committee says wars like Vietnam will never ever work. And so Dyson, between what he heard the general say and between this thing called the Oregon Trail Report, wrote up another report called the Tactical Nuclear Weapons in Southeast Asia Report, which was classified until 2002, but the title wasn't. And when the title became public, everyone thought that Freeman Dyson and his group of people were advocating the use of nuclear weapons in Vietnam, and it turns out the report was exactly the opposite. But of course, Freeman couldn't tell anyone that because it was all classified. He did make one statement while everything was still classified that everything in the report, I believe, was honestly and justly written. And it turns out when you read it, yeah, it all made sense. Okay. Okay, other cool stuff you got to work on is adaptive optics. Has anyone been to these places? Oh man, okay, you need to go. Okay, so in the summer, LBCC offers GS-106, which is a Quarks to Cosmos class. What we do is we start at the nuclear reactor at OSU studying atoms, and then every day for 20 days in a row, we do something 10 times larger than the day before until we end up at the Keck telescope up in Hawaii. So it's 10 days Oregon, 10 days Hawaii. Great class. It's a lot of fun. And what makes these telescopes so neat is that they have something called adaptive optics in it. One of the problems so the reason why we put the Hubble up in outer space was because there's no atmosphere to block the starlight from hitting us. It turns out the atmosphere garbles up all the light. So if you go into outer space, hey, you don't have to worry about the atmosphere anymore. Or you can build something like this. The Keck telescope fires a laser into the atmosphere. It hits strontium in the upper atmosphere, making a fake star. The star, of course, looks all distorted because of the atmosphere, but all those separate parts of the big mirror all vibrate to exactly compensate for the vibrations of air between you and the thing you're trying to see. Really super cool and amazing. So if you want to go see if you've ever wanted to go see the Hubble telescope, no, this is cooler. And you can go there just by taking GS-106 at LBCC. And although I love OSU, I do want to point out that LBCC's GS-106, including the fee to go to Hawaii, costs just as much as the OSU version of GS-106 that doesn't go to Hawaii. So take the LB version. Okay, and one of the things Freeman points out about adaptive optics was originally used The military wanted to look at it because there's this thing called Star Wars where we were going to put a whole bunch of lasers in outer space and shoot down missiles. I actually got to have dinner with Edward Teller, who is a person who Dyson worked with, and, well, different long story, but bottom line, adaptive optics was classified for a decade. So we ended up getting these telescopes 10 years later than we could have. And Dyson's summary of military and science is that the military slows down scientific progress because, number one, you consume all the brains that should be working on other problems, working on military problems, and then what they find gets classified. And so the book has a little bit of that in it. And finally, to summarize the end, 1980s and 90s, man, he does lots of stuff and likes his kids a lot. There's a great story in there of his son, his eldest son, moved to Vancouver and lived in a treehouse for 3 years, which is so opposite of Freeman's life. It makes you wonder, man, how well did they get along together? And then Freeman tells a story about he went to go visit his son in British Columbia, and as they were sitting eating lunch outside, they all noticed a capsized boat. And Freeman's son and a friend of his son instantly jumped into their boat, and without knowing that there were going to be bodies in the water, quickly discovered 2 bodies in the water that fortunately were still very much alive. And so they ended up saving 2 people's lives right then and there. So Freeman makes, in all the readings I've been able to do, Freeman doesn't ever say anything too strongly supportive and nothing critical either of his children, except for this. It's at this point he realized, oh man, maybe the best thing I ever did was make my son here. And since then, his son has done really cool stuff. He lives in Seattle right now, Bellingham right now, making kayaks, doing fun, neat stuff. And I think what Freeman liked about his son is his son, Oregon, British Columbia, we are kind of the last frontier. Only 2 generations ago, it was mostly Native Americans here, and 3 generations ago now. And so I think he liked that pioneering spirit he saw in his son. When you see something's wrong, you hop in a boat and you jump to action. And then the year 2000 to now, he almost died at University of Oregon. It turns out he was presenting at University of Oregon. He wasn't feeling very well, so he went to go lay down on a sofa. He did give his talk, but they rushed him to a doctor, and it turns out his pulse was 30 beats per second, so they put a pacemaker in shortly thereafter. Had they been only a couple days slower, he might not have survived that. And then if you go on and watch these particular YouTube videos of him, he describes himself now as a heretic. And one of the things you'll come up with a lot is global warming. So he in no way ever suggests that global warming isn't a reality. He knows it's anthropogenic, he knows people are making it happen, he knows that it's going to change things and it might change things quickly. But what makes him a little bit different is he says, so what? That's what happens. Humans change things. And I think that's made people be very critical of him. And I'll let you come to your own conclusion of that. He also has neat prophecies. He really thinks that gene tech is going to change the world, and I agree with that. And he kind of sees a near future where maybe for your 5th grade classroom, instead of burning chemicals that you're not allowed to burn in the library, you'll instead make baby dinosaurs or things like that. And of course, he argues there should be lots of regulation. But this is kind of his entire attitude towards science is, this is the path we're going. Let's just see where it brings us. So, very quickly, that was what I got out of the book, and I hope if you haven't read it, you spend a little bit of time reading it. Yes, so I think at this point we have time for questions.
Was he on teaching faculty? How did he get around doing all this research?
Okay, so he was a teaching faculty, so he did teach classes, but it sounds like in his particular position, it is very easy to say, okay, I'm going to spend the next year working on a nuclear reactor somewhere. But I think the most important thing was he always spent his summers doing something somewhere interesting. He would always bring his family there, so his family would go to the beach, and he would be in a institute somewhere working on some cool problem.
I was a graduate student at Cornell when Dyson arrived, and it must have been about 1950. And I was interested in the comments about Dirac's teaching style because Dyson did it exactly the same way. I took nuclear theory from him, and there was a big report that Blatt and Weisskopf had put out, a mimeograph, great big fat thing. And he simply sat up in the front and read the damn thing. No interpretation, no nothing.
Yeah, so again, so the question was about teaching styles. So one of the things that I'm interested in is how people learn physics. And I think one of the things we've learned is for 80% of us, simple lecture is not the way to convey information. Yeah. Any other questions?
How come this works?
Are, so we don't have to.
Sorry, say it one more time.
Can you tell us who the Jasons are?
Oh, the Jasons are. Okay, I need to learn more about the Jasons myself, but the Jason group is a group of roughly 30 people. It's funded by the U.S. government. The only way you get into it is if someone nominates you to be in it, and usually you're replacing someone who's leaving it. You have lots of impact upon policy. Generally, the Jason group is asked a question. Usually the answer is is this physically possible? That's usually what they contribute. But sometimes they influence policy.
What policy?
U.S. policy. And things like nuclear weapons, should we use them, and stuff like that. So I had a quick questions about the little plastic things you got. So those slides are diffraction gratings. When you put them up against your eye, you can see rainbows. It turns out that there's roughly 1,000 lines per millimeter etched into that piece of plastic. And because light is a wave, it turns out that ends up separating the different frequencies of light the same way that a prism does.
Yeah.
Okay, any last questions before we go? One more?
Is the author, was he a physicist, or what was his background?
You know, I did not investigate the author that much. I'm sorry, I really should.
Yes, he is a physicist. He's a PhD physicist, and he is primarily a science writer, and he is the lead writer for the American Physics Society Association.
The APS?
I can't remember what the name of it is. And he has written other books. He is a physicist, yes.
So I'll probably research that more later when I take a look at it. And when you read it, he's got the common problem of, oh man, I got to explain this physics, but I got to explain it in a way that's not going to turn readers off. And so I'd be curious other people's take on how well he achieved that.
I thought he did a great job.
Okay, so it's a couple minutes after the hour. I think we should call this a close. And if anyone has any other questions, come up and ask away. Thank you very much.